Good day, ladies and gents. Today we are going to be talking about weighted average. So the best way to understand this is this. Okay, well, first of all, a weighted average is the average of a set of numbers where certain numbers have more values or weight than the others. All right, what does that mean? So what that means is, so if we have a scale right here, so we have a balance scale. Now, right here, here's the fulcrum. So science. So here's the fulcrum. And if we have the fulcrum right here, it's balanced because we have 2 and 2. Now, if it goes like this, if I take this off, now this is heavier. So if that's heavier, then this falls over, right? Well, we want to still have the same amount here, but we want to keep this balance. So in order to keep this balance, this fulcrum is going to have to go closer to the heavy side, and now it will stay balanced. And us finding where the location of that fulcrum is, that is what weighted average is. So here's the weight. So there's 2 of these and only 1 of those. And finding where this goes will keep this balance. And that's what we're looking for right here. So if I put another one here, it'll stay balanced again. And then I'll go right here. If I put another one here, in order to keep this balance so it won't fall over, see how it fell over? So to keep this balance, this fulcrum is going to have to go closer to the heavier side just to keep that balance. So that's what we're trying to find. Where does this go? And sorry, it's a little, there it is. Now that's straight. Okay, so we're trying to find this location. So that is what weighted average is, trying to find where this fulcrum is going to be in order to stay balanced. All right, so let's go ahead and do some examples before we actually get into the worksheet. So I'm just going to do some examples that came from this awesome video from another gentleman, and I'm just going to go over it again. All right, so what we're going to do is if we have 5 kids and they're 100 pounds each, and we have one bodybuilder dad who is 300 pounds. So how do we get this going? So now average would say that you would add those together, divide by 2, but that won't find out where the fulcrum is. So basically, for weighted average, what we're going to do is, let me just put this here. Okay, so for weighted average, we would do, for the kids, there is 100, and there's 5 of those, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And there's a 300 pounder. Okay, divided by how many total were there? There were 1, 2, 3, 4, 5, 6 people. So 1, 2, 3, 4, 5, 6. So divide by 6. So you put that in the calculator. So always do the top just by itself. So 100 plus 100 plus 100 plus 100 plus 100. 1, 2, 3, 4, 5 plus 300. We got 800 over the 6 people. Now divide that. So 500, so that's 800 divided by 6. And we get approximately 133.33. We get approximately that number. So it's about 133 pounds. Right? Now, there's another way how to do this. So the other way, well, basically the same way. So there were, how many people were there? There were 5, and I like to write that number nice and large. There were 5 times the 100 plus, and there was 1 times the 300. So you see how I write that number really large, divided by, and how many total were there? 5 and 1 make 6. So, and then we would still get the same numbers, right? So that would be 500 plus that 300 divided by 6. That's 800 divided by 6. We get 133.33 again. So that's one way how to do this, right? It's a pretty quick, easy way. Same ideas. I like to also stack them on top of each other. So there were kids. So there were 5 kids. 1, 2, 3, 4, 5. And then there was one bodybuilder dad. So bodybuilder. and I like to stack them. So there was 100, 100, 100, 100, 100, and then the bodybuilder was 300. So, and there were, how many total were there? How many total? 1, 2, 3, 4, 5, 6. So what I like to do is add all those together. So 1, 2, 3, 4, 5, 6, 7, 8. So that's 800 divided by the 6, and that 6 came from over here. And then your final answer would be 133.33. So those are 3 different ways of how to do this. So let me zoom out again. All right, so one way is the big sentence where you're just adding them all together, divide. Okay. Another way is the equation way. The equation way says how many were there times so that's called the weight, and then this would be the value or the location. So times 100, and yeah, and then this way is probably the way that you're probably going to use the most. This is the easiest way. All right, let's do another example. All right, so for this one, I'm just, now that I show you 3 ways, I'm just going to do one and just be done with it. All right, so this way, okay, there are 1, 2, 3, 4 bodybuilders and 1 kid. So 300, I'll zoom in a little bit. So 300, 300, 300, 300, and then 1 kid, so 100. Okay, there are 1, 2, 3, 4, 5. There are 5 people. So 3, 1, 2, 3, 4. 3 times 4. Okay, we get 1,300. Just double checking this one more time. 300 times the 4. Okay, yep, 1,300 divided by the 5 people. So 1,300 divided by the 5, and we get 260. So that is, so the weighted average would be 260 pounds. And that's that answer. Perfect. All right, let's keep going. All right, so another example. So in this case, do you think you're really going to be writing 3,000 pounds 32 times? Probably not. So, so for that one, we would do, so there's 32 pounds. So this is supposed to be the yellow car, the blue car, the red car. Forgot to put those in there. All right, so for this one, we would do, there's 30, so we'll write this one really large. So 32 times the 3,000, 1, 2, 3, plus there are 5 of the 4,000, plus there are 7 of the 5,000, 1, 2, 3. All over. And how many total were there? Those are the big numbers, 32, 5, and 7. So 32, 5, and 7 add up to 44. All right, so if we put those all together, so 32 times 3,000 plus the 5 times 4,000 plus the 7 times 5,000. So I like to do just the top by itself. So that's 151,000 all over the 44. Divide those, and you get approximately 3431.818 blah 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 blah. So that's approximately equal to 343.2. Because you see the 8 right there, that would make it over the hill. So we had to decide of 3431 or 3432. So if the 8 on the afterwards makes a decision, so 0, 1, 2, 3, 4, because I can count. So if I drop it at the 8, it would roll to the next number. So, and that's our answer. Okay, and one more, and then we can actually start doing our worksheet, right? All right, so in this one, this is yellow, this is blue, and this is red. Okay, so in this case, same idea. There are multiple ways how to do this, but I like to stick with one way and just forever, right? So I'm not going to write this 73 times because, you know, we all have lives. So there are 73, write that nice and large, of the 3,000, 1, 2, 3, plus the 11 times the 4, 0, 0. Oh, that's 1,000, sorry, 0, 0, 0. Plus there are 16 of the 5,000, 1, 2, 3. all over. And how many total were there? There were 100%. All right, so if we put that in the calculator, just do the top. So just so you can see what I'm doing. All right, so parentheses 73 times 3,000 plus 11 times 4,000 plus the 16 times the 5,000. All right, we have 343,000 divided by 100. So we divide that by 100, and we get 3,430. And that's the answer. All right, so those were a couple of nice little recaps on that. Okay, so now let's actually do our worksheet. So for our worksheet, all right, so on this one, an example, for example, an iron bar has 2 metal balls. So ball. At its ends with different weights. Where should the triangle be placed to keep this balanced? So to keep this balanced, where would the weight have to be? So I'll just go like this right here. So we're talking about, zoom out a little bit. We have right here, we have 1 here and 2 here. So we do that, this sucker would fall over, right? We don't want that. So in order to keep this balanced, if I go over here, wouldn't it fall down again? Yeah, so it can't be at B and it can't be at A. Those don't work. So the only thing that works is if we have this closer to the heavier side. There we go. And that will keep it balanced. So the answer was C. The answer was C. So C is the answer. Zoom out a little bit. So C is the answer, and I'll keep it nice and balanced. All right, so on this one, okay, so the weight on the first one is 1 pound, and where's the location? So this is the location, that would be -1, and for the weight for the second one, that's 2, and the location is at 2. All right, so what did we do? So basically, you're going to just multiply these and divide by how many total there are, right? So for that one, it was the weight is 1 times it's at -1, right? And then plus the weight is 2. These big numbers are always positive, times the location, which is 2. And then how much weight do you have on there? 1 plus 2. So 1 plus 2 is 3. So that goes down here, 3. So only do the top first. So 1, just so you can see what I'm doing in my calculator, 1 times that -1 plus that 2 times 2. So that's the top 3. So that is 3 over 3, which equals 1. So if I put the fulcrum at 1, does that make sense? Yeah, it's closer to the heavier side. So that's the answer. So the answer is 1. All right. And yeah, let's just keep going. Okay, so number 1 here. Okay, so they said find the coordinate of P that represents the weighted average of C and D, where C weighs twice as much as D. So it has to weigh twice as much. So let C be 2 and D be 1. See, C is twice as much as D. All right, so keep it simple, right? These are the things that get multiplied. So it's 2 times its location, -1, plus we have 1 times its location, which was 5, all over, and then the weight, 2 plus 1, which equals 3. So how many were there total sitting on top of the scale? That would have been 3. All right, so let's just do the top by itself first. So we have parentheses, 2 times -1 plus 1 times 5, and we have 3. So 3 divided by 3, and that would be 1. So the location of the fulcrum would have to be at 1, and notice that we're closer to the heavier side, so that makes sense. So I feel good about that one. All right, number 2. The point of G weighs 3 times as much as C. So if G weighs 3 times as much as C, so G weighs 3 of C, so C would have to be 1. So basically, we're going to take these, multiply them together. So I'll zoom in a little bit. All right, so we have 1 times that -1 plus, and then these multiply together. There's 3 times that 11. And we get, and how many total were there? 1 plus 3, which equals 4. So divide by 4. All right, so in my calculator, we have 1 times -1 plus that 3 times 11. So the top is 32 divided by that 4. So divide by 4 and we get 8. So does that make sense? We're closer to the heavier side. Yes, it does. That does look like it makes sense. And there were other ways how to do this. So another way to do these problems was, so same problems. So we have C weighs twice as much, right? So there's 2 C's. So C was at -1, right? And D was at 5. All right, so there were 2 C's and 1 D, right? So there's 2 C's and 1 D. So 2 C's, 1 D. Now what was C? C was -1, D was 5, C was -1, so C -1 again, and D was 5. All you have to do is add those together. So -1 plus -1 plus 5. All you have to do is add those together and divide by how many there were. So -1 plus -1 plus 5, and you would have had 3 over 3. And you still got the same answer, right? Same idea. If we do another one, I'm just showing you different ways how to do this. So you just pick the way you like and just roll with it. All right, so same thing for number 2. C was at -1. G was at 11. There were 3 G's, and there is 1 C, right? So for that one, okay, there's a C, and there's 3 G's. 1, 2, 3. Now, what were they? C was -1, G was 11, 11, 11. All you have to do is add those together. So -1 plus 11 plus 11 plus 11, we get 32. There were 4 total. So 32 divided by 4, and notice that we still got the same numbers. These were just multiple ways how to do the same stuff. You just do what floats your boat. Okay, now some of you guys are going, well, I like this way, but when you start doing the actual points, it might make more sense to do it this way because that's how you're going to do the points when you're doing coordinates. All right, so here we go for number 3. So first of all, we have 2 problems here. So this is A, this is B. They said point D weighs twice as much as E. And then over here, point F weighs 3 times as much as D. So these are 2 different problems. So the first thing we have to do is actually find these coordinates. So D is at -4, 2. E is at 2, -2. And F is at 5, -4. So it's really important that you find those coordinates. All right, so we don't have a lot of space here, so the best thing you can do is actually turn your paper sideways and write it this way. All right, so for A, it says D weighs as much. So we have D and E. So let's go ahead and write down those coordinates. D is located at -4, 2. And E is located at 2, -2. So I just wrote down those coordinates. And they said that D weighs twice as much as E. So D, there's 2 of those, and E, there's only 1. So I'll zoom in now. All right, so what we're going to do is we're just stack one on top of the other. So there are 2 D's. 1, 2, and how many E's? Just the 1. All right, so D was -4, 2, and D was -4, 2, and E, there was 2, -2. And notice I don't put the parentheses while I'm doing my work or the commas. That way I don't accidentally think that the parentheses was a 1 or the commas were negative signs. So while I'm doing the work, I just leave it like this. All right, so all we're going to do is add these together. So -4 plus -4 plus 2. Now, do you have to show that? No. I'm just doing that for my notes. And same thing here, I'm just adding these together. So I'm just going to scratch this out because we don't have a lot of room. So -4 plus -4 plus a 2. So all I did was add those together. Zoom out a little bit. All right, so all I'm doing is adding those together. So I get negative 6 divided by, now how many were there? 3. So there were 3 total here. There's 3 of them. So that's where that number came in. All right. And then over here, 2 plus a negative 2, we get 2 divided by that 3. All right, see if you can simplify this. Negative 6 divided by 3 is a negative 2. And 2 over 3, we're stuck with that, 2 over 3. And that's your answer. That's it. Now, I want to double check that this actually worked. So this is my answer right here, but I want to double check. So this is really negative 2, and 2 divided by 3 is about 0.7 roughly. All right, I need to make sure that that is on the line. So let's check. So I put this on the line. So negative 2, and then 0.7 is not quite 1. Now, first of all, that is on the line. I feel really good about that. So that checks out. So then now if I put the fulcrum right here, and we said that D was 2 and E was 1, am I closer to the heavier part? Yes, that worked out. So putting it right here, the fulcrum, that does work. So fulcrum right here, yeah, I'm closer to the heavier part. Perfect. Okay, so now let's do B. All right, B, same idea. So for B, they said F is one of the coordinates. So let's write that down. So 5, negative 4. And then the other coordinate, D, they said we figured out was negative 4, 2. And they said F weighs 3 times 1. So F is 3 as D. So D is 1. All right, and let's zoom in a little bit. All right, I'm going to cover this up so you're not focused on it at all. There you go. Okay, so now let's just do it. So there's 3 F's, 1, 2, 3, and there's 1 D. All right, write down the coordinates. So 5, negative 4, 5, negative 4, 5, negative 4, and your D was negative 4, 2. Only helps if you can see it. Okay, so all you have to do now is add these together, right? So 5 plus 5 plus 5 plus that negative 4, and we get 11 over, now how many total were there? There were 4 points, so divide by 4. Okay, and we have negative 4 plus negative 4 plus negative 4 plus that 2. We have negative 10 over 2. All right, 11 divided by 4, we get 2.75. And then negative 10 divided by 2, we get negative 5. So this is one answer. If we need to leave it as a fraction, 11 over 4 and negative 5 would have been the other option. So both answers are correct. Now let's double check this actually works. Is this on that line? So positive 2.75. So positive 2.75. So closer to 3 here. And negative 5. So do I go down to negative 5? Uh-oh, something's wrong. So that's not on this line, is it? So positive and then negative 5, something is incorrect. So we need to double check that everything's okay, because that did not land on this line. Something is wrong. So we have to double check. So let's see. We have F was at 5, negative 4. Double checking everything. 5, negative 4. Yep. And we said that F, there was 3 of them. 5, negative 4, 5, negative 4, 5, negative 4. And then we also had D at negative 4, positive 2. Negative 4, positive 2. And I'm double checking all my counts. So we have 5, 5, 5, and negative 4, which is positive 11. That checks out. And then we have negative 4, negative 4, negative 4, which is negative 12, plus the 2, we got negative 10. And then, you ever feel like you do something wrong? 11 divided by 4. Right here. Okay, now what were we supposed to divide by? We were supposed to divide by 4 right here. So this was supposed to be 4. That's what the typo was right there. So, and I really did make that mistake, but you see how checking to make sure it's on the line is very important. So I was supposed to divide by 4. That was what the error was. Negative 10 divided by 4, this would be negative 2.5. So this is negative, so that's negative 5 over 2 or negative 2.5. That's what it was. So this was the error. Now let's double check again. Is this on the line? So we have this and negative 2.5. Yes, that checks out. That is right here. I feel really confident about that now. So if the fulcrum was right here, and in this case, we said that D was 1 and F was 3, and I am closer to the heavier part, I'm good. Remember, mistakes do happen, so always double check, and that's it. All right, so that was weighted average. I hope you guys have a great and wonderful day.